I'm James Lawler. Welcome to Climate Now and our third episode in our series on sustainable aviation fuel, or SAF. So as a quick recap, and folks can go to climatenow.com to listen to or read the transcripts from the previous episodes in the series. In our first episode, Beatrice Batty of Epic Fuels and Signature Aviation gave us an introduction to the world of SAF, the ways in which it can be produced, and the perspective of a buyer of fuel, which she is. In our second episode, we spoke with Bruce Fleming, who is CEO of Montana Renewables, which is one of the largest producers of SAF, on the business of HEFA SAF, that is, the kind of SAF that's made by hydroprocessing esters and fatty acids in the most common pathway to produce SAF, and the only one that is actually producing SAF commercially at any scale. My guest today is Stéphane Thion, who is the Vice President in charge of commercial activities at LanzaJet, which makes sustainable aviation fuel from ethanol, or the pathway we referred to previously in this series as alcohol-to-jet. The LanzaJet refinery in Soperton, Georgia, about 100 miles from Savannah, opened just this past January 2024, and is the world's first and so far only commercial facility to convert ethanol into sustainable aviation fuel. The plant is projected to produce 9 million gallons of SAF in its first year, that is this year. So with that, welcome, Stefan. Tell us about your background.
I've been in the chemical industry and sustainable fuel and renewable energy for almost 25 years. I was working at TotalEnergies prior to joining LanzaJet, and I was heading the sustainable aviation fuel and marine fuel activities. And my team and I were scoping most of the technologies and trying to figure out what was the best pathways to decarbonize both aviation and marine. And I came across LanzaTech. I was impressed with the LanzaJet technology and this ethanol-to-SAF platform. And so I joined them as the general manager for Europe, Middle East, and Africa. And as of January 1st of this year, I had the pleasure to become the VP of commercial globally for LanzaJet.
Could you explain the difference between LanzaJet and LanzaTech, which I understand are two independent companies that work together in some way?
In 2020, LanzaJet was spun out of LanzaTech. LanzaTech core business is transforming carbon into ethanol. And they've worked hand in hand with the Department of Energy in developing the technology. And they decided, once the technology appeared to be mature and it was ASTM certified, technically certified, LanzaTech decided to focus on their core business, which was transforming carbon into ethanol, and decided to spin off the aviation piece, creating LanzaJet. And in that instance, LanzaTech has brought on investors. So LanzaTech is a remaining shareholder of LanzaJet, and they brought up original investors that are Suncor and Mitsui, as well as the U.S. Department of Energy. And then we brought up new partners, British Airways and Shell, into the mix to support the deployment of our first commercial facility in Soperton, Georgia. So we're two separate entities because LanzaTech is a publicly listed company, and we remain a privately owned company. And we continue working together because we start our technology by transforming ethanol into sustainable aviation fuel, and LanzaTech is producing ethanol. So they're naturally a partner of ours in several of our projects around the globe.
Got it. So you've described LanzaTech as a company that converts carbon into ethanol. What feedstock does LanzaTech use for doing that?
Pretty much everything that is carbon. They have about 5 plants under operation today, 5 in China, and one that is being starting up in Belgium, in Ghent. And they take gas from carbon emission. It's not science fiction, it's real. They take off gas from steel mills or a combination of hydrogen and carbon to make syngas through a fermentation process. So basically bugs, they manage to transform those carbon emission into ethanol. So that's their core business. and we can start from municipal solid waste, agricultural waste, and of course, those off-gas or carbon emission that LanzaTech can transform into ethanol as well.
Okay. So they're transforming CO2 to ethanol.
Yes, they start with off-gas. So in some industrial process, especially the very hard to abate industry like steel mill or cemetery, you can capture those carbon emission, and through a fermentation process, you transform this carbon into an actual liquid fuel.
Yeah.
And the process is fully commercial and de-risked. Like I said, they already have 5 plants in Asia and 1 in Europe that are fully operational.
Wow. Is anyone else doing that?
This is proprietary. This is very unique. There's the first of a kind. They're really ahead of the game, and I'm sure there's some people trying to do very similar things, but I'm not aware of any other technologies able to do that today at commercial scale like they do.
Got it. So Lynn, let's move over to LanzaJet. So you take ethanol as a feedstock and you make kerosene.
Yes.
So this is known as an alcohol-to-jet pathway that you're pursuing. Just to remind our listeners, there's a number of different pathways that are either in use or proposed to create so-called sustainable aviation fuel. One is alcohol-to-jet. And correct me if I misspeak here, but this is still sort of a pre-commercial technology in the sense that it's not yet fully de-risked.
So it's not quite that. Actually, we're a lot more advanced than that. In January, we had the great honor of having a big celebration and opening ceremony of the first of a kind commercial ethanol-to-SAF facility, the first of a kind in the world. That is in Soperton, Georgia. It's between Savannah and Atlanta. Mm-hmm. And so this is one of the many projects that we have. So this one is fully commissioned almost, and we're expecting to produce the first sustainable aviation fuel volumes before the end of Q2, so this year. So you can think about this as being the first non-HEFA, because you talked a little bit about the other technologies out there, but this would be the first non-HEFA, fully commercial, sustainable aviation fuel available for the market.
Wow, terrific.
So this is quite innovative. And we have the intention to bring at least 3 million tons of sustainable aviation fuel production capacity by 2030. So that equates to about 1 billion gallons.
Billion gallons by 2030.
Yes, that's the intent. Correct.
Got it. So once you produce jet fuel at your Georgia facility, where do you send it? How does it get into airplanes?
So the sustainable aviation fuel, the pure, renewable fuel molecule, will be sent to Savannah. It will then be blended up to 50% with Jet A1 or the fossil kerosene. And then once it's blended up to 50%, the new fuel, the new blend will be recertified as a standard Jet A1. And then it can use, and that's the beauty of the sustainable aviation fuel, it can be used in the exact same infrastructure than the jet fossil for the airplanes. That's what we call a drop-in. So the blend of the two components together, up to 50% of SAF, can be used in existing infrastructure and airplanes. In our case, there's a pipeline, colonial pipeline, that serves Savannah, and the fuel will be put in that pipeline to feed the airports that are along the east coast of the United States of America.
Terrific. And who are the customers or off-takers for the sustainable aviation fuel being made at LanzaJet's Georgia facility today?
Actually, the off-takers of the fuels are our partners, all our investors, the Shell, the Suncor, British Airways, of course, and Mitsui have an appetite for SAF. Our plant is sold out for the next 10 years, so we don't have to worry about this one for both the sustainable aviation fuel and the renewable diesel. Because what I did not mention is that our process enable us to transform ethanol into renewable fuels, of which we can maximize the production of SAF by 90%, and we make 10% of renewable diesel. But we also have the ability to maximize the production of renewable diesel up to 75% and get 25% of sustainable aviation fuel.
I asked Stefan why, logistically, this facility in Georgia made sense for LanzaJet to use as the first producing facility for making ethanol into jet fuel. He explained that LanzaJet's founder had previously bought the land and built a pilot plant on it, and that local authorities welcomed having an ethanol-to-jet facility built in the area.
That's why we were there. It was a bit opportunistic. Mm-hmm. The beauty of this ethanol-to-SAF platform is the fact that we can use any kind of ethanol. So we can be using corn ethanol from the United States. We can use low carbon intensity sugarcane based ethanol from Brazil, advanced ethanol from lignocellulosic ethanol, or the ethanol that I referred earlier that is produced from carbon emission from LanzaTech. Any kind of ethanol we can process.
Where will you get the ethanol that you'll process into jet fuel?
So it's going to be a mix of various locations, but mostly it's going to be low carbon intensity from Brazil, as well as supply from U.S. source.
And how does it get to you? Are you on a rail line? Does it get to you by pipeline, or how does it come to you?
It would be a combination of shipping, so by sea, by ocean, as well as truck once it arrives in Savannah.
Can you talk about the economics of it? Are you selling the SAF at the same market price as fossil jet? Is it sold at a premium?
For those projects that we have in the United States of America, we can enjoy a series of incentives that we can stack. One's being the renewable fuel standard. And there's a second stack through the IRA, the Inflation Reduction Act, with a dedicated SAF blending credit. So with the SAF blending credit, you can make between $1.25 a gallon up to $1.75 a gallon of incentives. This is a national incentive. You need to have a minimum threshold of 50% reduction in greenhouse gas emission. So your SAF, as long as it has this threshold of 50%, you get $1.25. And for every additional percentage in reduction in greenhouse gas emission, you have an additional cents per gallon. And that's why you can go all the way to $1.75. And in addition to that, you have some state incentives, like in California, or in Washington State, in Illinois, and those incentives varies. They can be a flat incentives of a $2 per gallon in the state of Washington, $1.50 in the state of Illinois, or a value that will vary according to market condition based on carbon pricing in California, for example.
So with all those incentives, does it make this method of alcohol-to-jet profitable at the Georgia facility?
The purpose of the facility is to demonstrate the technology commercially. We're not going to make a lot of money on that first facility, which was calculated that way. And as we build more plants, become more efficient, scale up to gain a bit of economy of scale, and choose appropriate location, those projects will be very profitable.
So as you know, calculating the carbon intensity of sustainable aviation fuels takes into account the CO2 emitted during the life cycle of its feedstocks, that is, the emissions that occur during operations such as planting or harvesting and transporting. And I'm curious whether transporting your feedstock all the way from Brazil contributes significantly to the carbon intensity of the SAF that you make.
When you look at the carbon intensity of the transportation portion, it's not that big, actually. At the end of the day, the fuel that we'll be producing will achieve above the 50% reduction in greenhouse gas emission. So we will enjoy the stack of incentives. And depending on the type of ethanol, if you go to those advanced ethanol, those that are made from off-gas, carbon emission, woody residues, agricultural waste, municipal solid waste, you can tend to get to a SAF that is close to almost 100% reduction in greenhouse gas emission. But remember, the ultimate goal of this SAF is to adapt as much carbon as possible.
As you look at the landscape of different SAF technologies, production technologies, in particular HEFA versus alcohol-to-jet,
yes,
what do you see as the advantages of alcohol-to-jet? And do you think that alcohol-to-jet will be more successful than HEFA in the long term? Or
absolutely. So just to put things in perspective, we will need more than 400 million tons of sustainable aviation fuel by 2050. 400 million tons. Probably less than 400,000 tons was put to consumption last year. So there's a huge effort in deploying sustainable aviation fuel capacities to get to that net zero 2050 that the aviation sector is trying to achieve. If you look at the ramp up of SAF, they stack it into 4 brackets. You got this HEFA technology, which is the hydrotreatment of ester and fatty acids. So it's converting those used cooking oil, animal fat, and virgin oils into sustainable aviation fuel. Then you got this alcohol-to-jet, so the ethanol, methanol, isobutanol, you have different types of alcohol. You have the gasification Fischer-Tropsch, which is starting with more of solid waste that you gasify into a syngas, and then through Fischer-Tropsch make sustainable aviation fuel and other types of fuels. And then the holy grail that everybody is wishing for is this power to liquid. So starting with a renewable energy into a green hydrogen combined with a carbon, direct air capture or other types of carbon to make sustainable aviation fuel. There's been several analyses that shows that HEFA, because they will be limited in the amount of feedstock that they can source. 20 million tons of SAF or 30 million tons, let's say no more than 10% of the future market in 2050. 20 million tons would be 6 billion gallons. 80% of the rest of the SAF that will be required will require a technology that is different from HEFA. The one technology that is coming right next after HEFA is alcohol-to-jet. And the reason being, there's plenty of ethanol available today. The supply of ethanol annually in North and South America is about 22 billion gallons. And there's more than 15 billion gallons in the United States. And when you think about electrification of the road market, there will most likely be less and less of this ethanol being used in the road. So it gives an opportunity for those ethanol producers, a great opportunity to reach a new market. And we could take that ethanol and convert it into SAF. The beauty also of this ethanol platform that I mentioned earlier is the fact that you can use any kind of feedstock and turn it into ethanol. You can use municipal solid waste, agricultural waste, or even a combination of green hydrogen with a carbon to make a syngas. That syngas can be fermented by our friends from LanzaTech to make ethanol, and then ethanol to SAF. And then you have this very flexible platform of existing ethanol supply, plus all this future ethanol that is being developed as a potential feedstock to serve alcohol-to-jet facilities. So that's the main advantage of the technology. And in that sense, we compete directly head-to-head with those gasification Fischer-Tropsch project, because instead of gasifying those feedstock into a syngas and putting into Fischer-Tropsch, you can ferment those syngas into ethanol and ethanol to SAF. Same thing with power to liquid. So when we look at the potential for alcohol-to-jet technology, in our view, our market play is 80% of the SAF that will have to be produced by 2050. So it's a huge market opportunity.
Mm-hmm. Now, when producing the syngas from your feedstock, does that happen through a gasification? How does that happen? Don't you have to gasify the feedstock?
So we have 2 types of projects, what we call a standalone project, where we would offtake ethanol that is produced today and converted into SAF. And then we have a bit more complex project that integrate other technology partners. I'm going to give you an example. We have a project in the UK called Speedbird. It's a project that we're running jointly with British Airways. We're going to be producing 30 million gallons. And we're working with a technology partner, Nova Pangaea. They have a technology, it's a pyrolysis technology that converts agricultural waste into a second generation ethanol. And we'll take that ethanol and convert it into SAF. We work with other partners in some other parts of the world where we would start with municipal solid waste. We have a technology partner that will gasify that municipal solid waste to create the syngas. That syngas will then be converted into ethanol through the LanzaTech technology, and we'll take that ethanol and convert it into SAF. So we have those various projects, either as a standalone or integrated with technology partners.
Stefan then noted that the beauty of the fermentation process used by LanzaTech is that even when different feedstocks are used, the microbes produce a consistent final product.
The magic behind the fermentation, bugs adapt. So the syngas can vary in quality, and because you'll get a variation of syngas quality based on what kind of feedstock you will process. So there will be a variation. But the fermentation process from LanzaTech enable a very consistent outcome and production of ethanol at the back end. And that's where is the biggest advantage. So you can process a lot more in quantity and quality of feedstock. And at the end, you'll get a very consistent yield of syngas to ethanol. And gasification, the complexity is those type of feedstocks, so that are not coal or that are not natural gas, to process that into liquid fuels. And that's where the challenge lies when we use the combined technology of LanzaTech and LanzaJet. You don't have that complexity anymore. So you put all these together and it makes something that is very attractive, fully de-risked and commercialized. We know that we've seen some players in the gasification Fischer-Tropsch space that have been struggling.
And it's not just with the Fischer-Tropsch; it's with the gasification step is a key. It's proven to be very difficult, even if you have, with non-coal, non-natural gas, even using woody biomass that's been uniformly processed. You still have a lot of variation in that feedstock, even when you do that. So I think, the gasification has been a struggle. It's not yet permissible to use pure or so-called neat or unblended sustainable aviation fuel in jet planes. Instead, SAF has to be blended with standard jet fuel so that it makes up no more than 50% of the final mixture, which of course means that emission reductions are not as great as would be possible if planes could use pure SAF. So why is it that pure SAF can't be put directly into planes?
One of the main difference when we make those sustainable aviation fuel from biogenic material, we're not producing aromatics. And the aromatic component is an important component into the Jet A1. And all the airplanes today, the infrastructure, the engines, the system of an airplanes have been built around the chemically, Jet A1 composition. If you were to take that aromatic component out and use 100% paraffinic type of material, like the one we produce when we make the SAF from any of those pathways that are approved today, it wouldn't be a drop-in.
What has LanzaJet's financing strategy been to date?
The company has been in a growth mode. When I joined the company, we were about 50 employees. We doubled the size of the company in the last year. We anticipate to grow the company further. We have the ambition to build up to 3 million tons of sustainable aviation fuel capacity by 2030 on the number of projects. And what's interesting to see is most of the projects are fairly balanced in terms of geographies. 1/3 of them in the Americas, 1/3 in EMEA, Europe, Middle East, and Africa, and 1/3 in Asia Pacific. And they're split about 50-50 between standalone ethanol-to-SAF, as well as integrated technology solution. We anticipate to sign many feasibility study this year and an advanced project in basic engineering design and feed. Southwest Airline is a new equity shareholder of LanzaJet. Recently, we announced Microsoft joining us, and there's a couple more to come in the near future. So stay tuned. But it's going quite well, and expecting a accelerated growth. All our equity shareholders, they have a variety of interest. Microsoft has been a supporter of LanzaJet from the beginning. They've provided us with a $50 million loan for part of financing of our facility in Georgia. They are interested in renewable diesel. They're interested in SAF to reduce their overall carbon footprint. We had a loan guarantee from the Department of Energy. Southwest deal is a bit different. Southwest have been at the forefront of decarbonizing aviation. They've invested in a company called Sapphire that is producing ethanol from corn stover. They recently acquired 100% of it. And there is a fit between the two companies because Sapphire would produce the advanced ethanol. We would process it into SAF, and Southwest would dedicate a production facility to process their Sapphire advanced ethanol into SAF for their use in their commercial airplane.
That's it for this episode. This is the third in our series on sustainable aviation fuel. Our next few episodes will explore the biofuels and SAF markets globally and how renewable fuel credits work to both support and surprise that market. We hope you'll join us for our next conversation.